Thank you very much, Patrick, and thank you all for coming. I've never seen a crowd like this before. I suspect we could be here for the rest of the afternoon. Also, thanks to Alistair and Peter for arranging today. I know you've been working hard over lunch, because you've got a summary of what I'm going to say, so I can almost finish now because you've all been studying that carefully. A full copy of the text, what I'm going to say, will be available after. Now, you're going to get, unfortunately, 8 graphs prepared by Tom Quirk, and he's going to show us the main points in them with a little red button, I think. Today is a very important day, as you probably read in your Australian. It's the end of El Nino, so now we're going to cool down and get some rain. So, my thesis today is that despite the continued claims reported in the media, there is minimal risk that continued usage of fossil fuels will produce temperatures which become dangerously high. There is therefore no sound basis for governments to continue with expensive policies aimed at reducing the use of coal and other fossil fuels. Historically, there have been many examples of doom and gloom which did not eventuate. These include economist Jevons' 1865 book expressing concern that excessive use of coal was threatening to exhaust all coal supplies and stop economic growth. This followed the thesis promulgated by Malthus in 1800 that population growth must be stopped altogether, and was again utilised in 1968 by US demographer Dr. Pearl Ehrlich. Then, in 1972, a large number of eminent scientists, so-called, including 5 fellows from the Royal Society, supported Ehrlich. In that same year, the Club of Rome predicted that without government intervention, growth would stop within 100 years. For some time, we've also now had the Intergovernmental Panel on Climate Change, the IPCC, predicting dangerous temperatures unless we stop using fossil fuels. Now, by contrast, the 2007 book, Scared to Death, by Christopher Booker and Richard North. I can recommend this book, not simply on global warming. He discusses and analyses a whole series of proposals by scientists that governments need to intervene, or else we'll all get sick, or we'll die, or we'll eat too much cheese, or the wrong sort of cheese. So it's a really fascinating book. And increasing numbers of organisations and individuals, both here and overseas, have expressed sceptical global warming views in books and articles, including a petition by over 30,000 scientists in the US. My talk today draws particularly on research and advice by physicist Tom Quirk and meteorologist Bill Connenmouth, who was former head of the Australian National Climate Centre. There is no consensus that science justifies stopping the usage of fossil fuels. My own experience over the 28 years I worked in Federal Treasury is that professional scientists and economists often seek government action or funding to prevent wrongly perceived looming problems. When in 1972 I was temporarily researching at the Royal College of Defence Studies in London, I was given an excellent award by my analysis of the deficiencies in the thesis supporting the much publicised idea that there are limits on the supply of resources. However, almost all governments and United Nations agencies still accept the dangerous warming thesis, and through the IPCC they've tried for over 30 years to reach agreement on action to prevent temperatures increasing by more than 2 degrees centigrade. Not only have they failed, temperatures have also failed to increase over the past 17 years. This has given sceptical views some recognition. I want now to consider deficiencies in the dangerous warming thesis. I do so not as a scientist, Paddy, but as an economist with experience in recognising claims which exhibit many uncertainties. You don't have to be a scientist to find mistakes in assessments made by scientists. So, firstly, I'm going to try to explain the theoretical explanation about the dangerous warming thesis. This derives from the fact that a proportion of emissions of carbon dioxide from the usage of fossil fuels remains in the atmosphere. What happens to it there? The CO2 in the atmosphere is open to heating from the surface of the Earth, which of course is itself open to heating from the sun's radiation. Some of this heating of the CO2 in the atmosphere is in turn radiated back to the surface and increases the surface temperature as though in a greenhouse. However, warmist believers argue that the apparent increase in global average temperatures of about 0.7 degrees centigrade over the past century is predominantly caused by this so-called greenhouse effect. This is argued to eventually raise temperatures to levels threatening human existence unless usage of fossil fuels stops. One problem with this thesis is that the heat radiated back to Earth from the CO2 in the atmosphere is offset by evaporation, which absorbs heat and thus reduces the greenhouse effect. Expert opinions differ about the evaporation reduction effect, but it is widely accepted as significant. Now let me just recap in a simplified way the 5 main points about the warming process. First, some of the CO2 from fossil fuels stays in the atmosphere and is an addition to it. The remaining CO2 is exposed to heating from the Earth's surface, which is itself heated by the sun. Thirdly, this heated CO2 also radiates back towards the Earth. However, some of the radiation back to the Earth's surface is subject to evaporation. And finally, there is dispute over the net effect on temperatures. Another problem with interpreting the greenhouse theory is that it is based on research made many years ago, suggesting that 55% of emissions from fossil fuel usage, stay in the atmosphere. But recent research by Tom Quirk suggests that only 16% may be staying in the atmosphere. Now, if concentrations are much lower, that would of course have a much smaller upward effect on temperature. Now, I'm going to start with figure 1, I hope. Yes, good on you, Tom. What is actually supposed to have been happening to temperatures and CO2? Figure 1 compares what has happened to atmospheric CO2 concentrations and global surface temperatures since 1900. The temperatures, which are those used by the IPCC, are shown by the purple square lines. You got those, Tom? You find those? Yes, good. The CO2 concentrations are shown by the brownish circles, with the continued line marking the periods of the Pacific decadal oscillation. We've got the brown one, and then there's a continuous line going right up. Okay, now what is the picture that, I should say before I go on, the Pacific decadal oscillation reflects natural influences on temperatures, arising from the replacement of cold water on the western coast of North America with warm water. And there's obviously no causal connection with fossil fuel emissions. So what is the picture that emerges from this over the period since 1920? On the left axis of this graph, you'll see CO2 concentrations increased from about 300 ppm to 400 ppm, about 30%, as growth in world economies brought strong increases in emissions from fossil fuel usage. But what happened to average global temperatures? It's in the right-hand axis, they increased from 14.6 to 15.8 degrees centigrade, an increase of only about 7%. So you've got 30% increase in concentrations, 7% increase in temperatures over this period. In other words, temperature levels have increased much less than the increase in CO2 concentrations. Now, Tom, we're going to have a look at the little table. Good. Excuse me. A comparison of the two time series clearly indicates that there is no correlation between changes in the two. This comparison is summarised in Table 1. So on the left-hand side, you've got 4 periods covered: 1922 to 47, 48 to 76, 77 to 2000, 2001 to 2015. Then on the third part of the table, you've got global temperatures percentage increase every 10 years. And then on the final column, you've got annual increases of CO2, annual increases. What this shows it is that there were 2 periods, one from 1948 to 1977, and one from 2000 to the present, during which temperatures were relatively stable. In fact, if you look at the temperature column, you'll see from 48 to, it's actually got 1976, it actually fell in that period. Even though concentrations levels increased quite strongly on both in 48 to 76 and 2001 to 2015 again. The table also shows a period when both temperatures and concentration levels increased, but where the Pacific decadal oscillation was clearly a major contributor to the temperature increase. It is only in the period from 1922 to 47, that's the first line in the table, that changes in concentrations and temperatures appear to be correlated. But usage of fossil fuels in the 1920s and to 40s would have been relatively small. So my assessment from looking at these temperature and concentration changes is that it's very difficult to justify the conclusion by the IPCC and some others that a causal correlation exists between changes in temperatures and CO2 concentration levels. Right, now Tom, we're going to have a look to see what the chaps did at COP21. Right. So the Paris meeting in December 2015, you all have heard about that. What did they actually agree? At the end of 2015, 189 countries submitted pledges to the 21st meeting on climate change, the so-called COP21 in Paris. These pledges to reduce emissions are voluntary, and there's no supervision of progress reports to the UN. It is of some interest that the submission to the United Nations by Bolivia declared that capitalism is a system of death, and North Korea will have no difficulty in further reducing its emissions, as already no electric lights are allowed to be switched on during the night time. The analysis in Figure 2 by Tom Quirk is based on the top 12 countries. Top 12 countries for broadly defined greenhouse gas emissions, and that covers about 72% of the world total. The pledges have been standardised by Tom to be from 2012 to 2030, as countries have chosen various starting points, so they've been standardised. So please note, you may be surprised, before I go on, you may be surprised to learn that these pledges for greenhouse gas emissions would actually see a 23% increase for this group. And there's nothing about temperatures. It's clear, of course, that China, and you can see it on the graph, is both the major contributor to the increase and the source of the greatest uncertainty. One other important point arising from the Paris meeting is that there was no discussion on limiting CO2 emissions from forest and peat fires. No discussion at all. No estimates of these emissions are included in the total, but they are, in fact, these emissions from forest fires and so on are about 50% of global CO2 emissions. In short, even if the pledges are met, total emissions could be even higher than pledged, or they could be quite a bit lower. However, what is clear from the pledges is that China and India will become the largest emitters of greenhouse gases, with rises in the standard of living in both countries. Who is going to stand up and say you shouldn't be doing that? I haven't heard anybody so far. Tom, incidentally, has a lot more detail about the performance of individual countries. He can talk about, and it's attached to the text, but he can talk about it later if you want. Now, let's move on from that to the question about whether the temperatures actually published are accurate. So, first, figure 3 shows published from figure 3, temperatures are calculated, shows by the Bureau of Meteorology only by averaging the minimum and maximum. And that applies not only in Australia but overseas. The averaging looks logical. Minimum and maximum, add them up and divide by 2. However, what if Australia's average temperatures were calculated from temperatures recorded every 30 minutes? And this is where you come to figure 3. Research by Tom Quirk shows that in the central desert region, such as Alice Springs, the average over 30 minutes is about the same as the averaging of maximum and minimum. But in coastal and inland areas, such as in Cairns, which is on the left-hand side, averaging a minimum and maximum produces temperatures about 0.6 degrees higher than if the averaging is done on a 30-minute basis. What does that mean? The research suggests that an overall upward bias exists in the published daily Australian temperatures of about 0.3 or 0.4 degrees. Now we get to figure 4, Tom. Now, second, it appears that the Bureau of Meteorology calculation of Australian temperatures has not taken account of the heat island effect, which keeps temperatures up when recorded in large built-up urban areas. Figure 4, comprising the maximum and minimum temperatures at the Bureau of Meteorology office in Melbourne, compares that with Laverton, shows similar maximum temperatures but much higher minimum for central Melbourne because more heat is retained in urban Melbourne. So there's clearly an upward bias there. Thirdly, there's no graph for this, although lots of graphs have been produced about it. Although a recent review of temperature record of the Australia's Bureau of Meteorology stated that it could not conclude whether there has been an upward or downward bias, it indicated that it was uncertain about the adjustments made by the Bureau of Meteorology to the raw temperatures. That is, the temperatures initially recorded but then adjusted by the BOM. Submissions by independent experts such as Jennifer Morosi justifiably claim that the adjusted temperatures have an upward bias. What conclusion can be made about the accuracy of the temperature increase of about 0.8 in Australia degrees since 1900? One possibility is that about half is incorrectly calculated and the other half may well reflect natural causes. That's the Pacific decadal oscillation I talked about. But even if the published data was accepted, it's relevant that temperatures were higher in the medieval warming period from about 800 to 1100 AD, and also in the earlier Greco-Roman period. Yet there were few fossil fuel emissions then. In fact, the temperatures in those periods were likely higher than the scare temperatures promulgated by warmists that they should not increase by more than 2 degrees since industrialisation. So now we move on to the next one. What about droughts and rainfall? Much attention is given in the media and of course the ABC and elsewhere to areas experiencing below average rainfalls and droughts, and claims are made that these illustrate the effects of global warming. However, an examination of the variations in the Murray-Darling Basin's rainfall, annual rainfall, shows no connection with levels or variations in Australia's average temperatures. And the Murray-Darling Basin, just incidentally, is the one that our friend, what's his name? We call him Gumnut, don't you? What's his name? Shepherd, Melbourne University, keeps on predicting the Murray-Darling Basin is going to act out of existence. Indeed, there's no statistically significant change in the Murray-Darling Basin rainfall since 1900. Now we have a look at Antarctic and Arctic ice sheets and sea levels and the Great Barrier Reef. Figure 6 to start with. Sea levels have been increasing over recent years, and if higher temperatures cause large ice sheets and glaciers to melt, sea levels would rise further and low-lying land would become more susceptible to flooding. In fact, in Australia, some owners of properties close to the ocean are already being stopped from development by measures that have been introduced by councils because they accept such alarmism. However, IPCC reports have predicted much higher sea levels than actually occurred. Satellite measurements of sea levels from 1994 show an average rate of increase which, if continued, would result in levels about 30 centimetres higher by 2100. Now, I don't know, 30 centimetres, about that, is it?
About a foot.
Yeah. Most residences would readily be able to protect themselves against the occurrence of such an increase over a century. Now, as to ice levels, figure 7, until recently the extent of ice in the Arctic had been falling, even though global temperatures were not increasing. But in any event, melting ice in the Arctic has no effect on sea levels because the ice there is already floating in the sea. The Northwest Passage across Canada has in fact been navigated in earlier periods when fossil fuel usage was low. In the Antarctic, the total ice area has been increasing and recently reached record levels. Break-offs of sections of the Antarctic ice sheet attract media attention, not to mention the CSIRO, but such break-offs are normal. Satellite data covering the past 30 years show a distinct cooling in the Antarctic region. As to the Great Barrier Reef, alarmism by conservation bodies have been shown to be unwarranted by the declaration last year of an international heritage agency that the reef is not in danger of destructive bleaching. Most of the reef recovered from the bleachings of 1998 and 2002, which probably resulted from the temporary warming of seawater during the light winds which occur at the time of El Niños, and that limit the flow of cooler water across the reef. There are present concerns about the reef, but the Reef Authority itself recently said it's too early to assess the extent of damage from bleaching. Some of you may have seen Sir David Attenborough's program on the Great Barrier Reef on the ABC last week. It was a really good program. Attenborough claimed in that program that the reef is 10,000 years old. That suggests it has already experienced temperatures higher than the present or recent ones. It is also important to recognise that any action by Australia to deal with the Great Barrier Reef, but any action to reduce emissions by Australia would not help protect the reef unless there's a big international agreement amongst major emitters that was enforceable. Now, I'm on the last graph, I hope. Here we are. This is a real monster. A key temperature test is to examine the predictions used by the IPCC, which have been calculated by modelling. Figure 8 shows that none of the supposed expert modelling used by the IPCC as a basis for its predictions coincide with actual temperatures published and shown in the figure as observations. The published measured temperatures are much lower than model predictions. These are the circles. Can you show the circles and the squares at the bottom? You've got a red button there, Tom. Up a bit.
There we are.
Yeah, there we are. That's the actual, and there's everybody, all those modellers. The marked difference shown between global temperature predictions and measurements published is, however, is still said to support the dangerous warming thesis. The difference for the years 2001 to the present is said to be the missing heat has gone into the sea, but little or no increase in ocean temperatures has occurred, and the missing heat is yet to be found. Most scientists do accept that if atmospheric CO2 were to be doubled from the existing 400 ppm to 800 ppm, this would be likely to raise the global temperature by 1 degree centigrade. But models predicting rises of 2 to 4 degrees centigrade to the end of the century do not take account of evaporation, which reduces upward radiation. So, ladies and gentlemen, I've got 9 points for my conclusion, just to jog your memories, in case you forgot what I said earlier. First, there are fundamental, and yes, you've got your summary of what I've been saying, supposedly. Firstly, there are fundamental faults in the statistical and scientific analysis used to justify the need for early, comprehensive mitigatory action by governments. Second, claims of a consensus on the IPCC science have no credibility, and account is not taken of the long history of faulty analyses by scientists more generally. Thirdly, examination of the temperature and CO2 concentration data indicate that any greenhouse effect on temperatures to 2100 is likely to be very much less than the IPCC and others predict. Fourthly, there is no satisfactory explanation of why temperatures did not increase during two lengthy periods when fossil fuel emissions did so. Fifth, new research adds to existing evidence that temperature increases in the last 100 years or so have been considerably overstated. Sixth, new research also suggests that the extent of carbon dioxide in atmospheric concentration is much smaller than previously thought. Seventh, there is no substantive evidence of threats from rising sea levels or melting sea ice in the Arctic or Antarctic. Eighth, there is no evidence of any significant change in average rainfall or that droughts or other severe weather events are likely to occur more frequently. Even the IPCC agrees with that. Finally, as pointed out by some analysts, such as Lord Ridley, the increase in carbon dioxide over the last century has been beneficial in allowing and encouraging additional growth of vegetation. In a word, my assessment is that the best policy for governments, businesses and individuals is to adapt to changes in climate and welcome the additions to CO2. Thank you, ladies and gentlemen. Questions?